Good morning. In this lecture series, we see about the global stiffness matrix for the stress. So, as we know that the global stiffness matrix is a combination of the local and the local stiffness matrix, and combined together, how many elements is there? Okay, we already discussing in the one-dimensional problem. Now we have to moving in the stress problem for the to frame the global stiffness matrix. So, the first of all, the global stiffness matrix for the stress in a finite element analysis. So you have to understand it is one of the mathematical foundation of the structural behavior of the and especially for the systematic analysis. Okay, so what is the stress? We know that the stress is called as a combination of members and joint and the supports. Okay, so why we are to using the truss and why are we use the FEA? So the stress structure, the stress is a efficient load bearing structures composed for the slender member connected at the pin joint. So these members carry only the axial loads, either tension or compression. As you know that the tension is an elongation and the compression is the acting the force on the towards each other. So making them to ideal bridge roof under towers. So what are the FEA approach? The FEA approaches are the finite element as, analysis is a systematically break down the complex stress system into the manageable element and the nodes. So by assembling the individual element stiffness matrix into the comprehensive global stiffness system, so engineers can accurately calculate the displacements and the internal force through these structures. So degree of freedom of the 2D structure. So as we know that the nodal degree of freedom, the degree of freedom we have to classify into major three. One is nodal degree of freedom, next one is element degree of freedom, and is the global numbering. So what is the nodal degree of freedom is? The each node possesses the 2 degree of freedom representing the displacement and the capabilities in the both the x and y direction of the coordinate plane. So what is the element degree of freedom means? The single stress element connected two nodes and resulting in the 4 total degree of freedom per element. So what is the next? The next one is global numbering. The global numbering of degree of freedom are systematically numbered across the entire structure with restrained degree of freedom are support excluded or specialized treat during the analysis. So now we understand this diagram. So the top layer we have to consider as a DOF label and the number of DOF 1 to 4 nodes. Here the node B shows the x1 y displacement across and node A we have to represent the x1 shows the x and y displacement arrows. Okay, so as the next one, the formation of the 4 by 4 global stiffness matrix. So what is the called as 4 by 4 means? This called as the 4 rows and the 4 columns. So as the here the matrix composites of the stress we have to represent as a KE is equal to AE by L. That is the area, Young's modulus, and the length. So here we have to represent as a L square LM minus L square minus LM and the LM M square minus LM minus M square and minus L square minus LM L square LM then minus LM minus M square LM and the M square. So this is the global stiffness matrix for the combination of the cosine terms. Okay. So what are the key properties of the global stiffness matrix are? The first one is symmetry and the sign pattern and numerical stabilities. The symmetries are the matrix is the systematic about the diagonal and ensuring the energy consistency. The sign patterns are diagonal entires or the positive vestals of the diagonal terms may be positive or negative that reflect at the equilibrium. The numerical stabilities, the structures ensure the well-conditional solutions behavior. So the summary of the importance, the first one is the analytical backbone and the accuracy of the assurance, engineering applications, and the professional masteries. So during the analytical backbone, the global stiffness matrix from the mathematical foundations of the stress and the FEA, encoding the all the structural behavior. So accuracy assurance, the rigorous element formulations and the systematic assembly procedure and guarantee reliable structural predictions. So engineering applications, they enable precision prediction of the displacement stresses and the internal force for the design optimizations. The professional mastery, the deep understanding of this concept and indispensable for the advanced structural and mathematical practical. So the summary of the overall global stiffness matrix in Truss analysis, we have to classify into 6. One is the local stiffness matrix, or the transformation and the assembly process, matrix function, analyze steps, and the methodology. So the local, that means local stiffness matrix, that is a primary we have to classify as a member length, and the assembly process we have to classify as a member connectivity, joint equilibrium, and the capability. So matrix functions, the force displacement relations and nodal force displacement mapping. So analyze steps, apply boundary conditions, solve the nodal displacements, determine the member force, and calculate the stresses. So these are the widely using for the there is a global stiffness matrix for overall summarize. Thank you.